Hello there and welcome back to the Aqua Open Source YouTube channel. My name is Anais Urlichs. I'm the Open Source Developer Advocate here at Aqua. Now this video is about the different installation options for the Trivy Operator. The Trivy Operator is a Kubernetes operator to install and run Trivy on a continuous basis from within your Kubernetes cluster. Now in this video, we're going to showcase how you can install the Trivy Operator first through Terraform resources, Terraform configuration files, and then through ArgoCD resources to manage the Trivy Operator Helm chart through GitHub's best practices. For further information between the difference of the Trivy CLI and the Trivy Operator, check out the blog post on the Aqua Security blog that's linked below in the description of this video. Also, the repository is linked below in the description of the video that showcase the different manifests, different configuration files that I'm about to show you. Let's get started. The Trivy Operator is part of our Aqua GitHub organization, Aqua Security GitHub organization. Now, Trivy, the Trivy Operator and related resources are all open source. You don't have to sign up. You don't send us any data. We don't even know if you exist unless you give us a star on GitHub. And we really hope you do, because that way more people can see our resources and our amazing projects. Now, the Trivy Operator is here. This is the repository. You can find the different installation options. The main ones that are provided through Trivy Operator here. It's a Helm chart and then the static Kubernetes YAML Manifest that you could use as well. Now in our case, we are mainly going to work with the Helm chart. Then from the main repository, you can go ahead to the documentation, and within the Getting Started section of the documentation, you will find the Helm installation. And this is usually the installation that I use in all of the other videos. So we are not going to go through that one just in this video. Check out the video that's linked below on my own YouTube channel that gives you an overview of the Trivy Operator and really details the Helm installation. If you're new to the Trivy Operator, that might be the best resource to get started for now. Now, also here we have the kubectl installation of the pure Kubernetes YAML Manifest. So that is another way that you could install the Trivy Operator. Now in our case, we're going to first install the Trivy Operator through Terraform. What do you need to follow this tutorial to install the Trivy Operator through Terraform? Well, first, make sure that Terraform is installed. So Terraform version, and here's my version of Terraform. And then you need to have, kubectl installed. And you need to have access to a Kubernetes cluster. So in this case, I'm running a one-node kind Kubernetes cluster. All of the resources that I'm using within this video are based on this repository. Now, this repository lists the different installation options, including kubectl and Helm that I just detailed. And then you can find here at the bottom the different steps to use the Terraform installation. Now, I have here a Terraform directory within this repository with a provider file. The provider file has access to the Helm provider as well as to Kubernetes. And then I have a Trivy Operator.tf file. Now, the Trivy Operator.tf file uses the Helm release and the Aqua Helm repository with the different Helm charts. And then the chart name is Trivy Operator. And then we're going to also set one of the Helm values for Trivy ignore unfixed to true, meaning we only want to see vulnerabilities, security issues that already have a fix available. So this is defined here within the Terraform directory. Then I have two additional files, a variable.tf file and a terraform.vars tf-vars file, where I'm basically setting the cluster name. So if you're reusing my resources here, make sure to change the cluster name as the variable. Now back in the terminal, what I can do now, I can go ahead and initialize the Terraform repository. So as you can see, I'm already within the Terraform directory. So I can say Terraform init, and this initializes the Terraform backend. And then I can say Terraform plan to see what is actually gonna get installed within my Kubernetes cluster. So we'll add one resource here, the Helm values that we'll set, and this is the Helm chart that I will install. As you can see, this is from the Aqua repository Helm charts. And then here's the version, so this all looks great. So here you can see the different values, and if something doesn't match your expectation, you could change the values within the Terraform resource. Then I can go ahead and say Terraform apply. And this is going to install the Helm chart. I already looked at those values, so yes, I want to install those, and this is going to create our Trivy Operator Helm release within our Kubernetes cluster here. Okay, so this resource has been added. Now, something else I want to highlight is that within the Terraform Trivy Operator.tf file, we are creating here a new namespace for this Trivy system. Now, the operator is going to get installed by default into this namespace, but we have to make sure that the namespace is going to get created. So back in the terminal, we can look at our Kubernetes cluster. So I'm just going to open our Kubernetes cluster in K9s. And here we can now see that there's a Trivy system operator pod running. I can look at the different namespaces within my cluster. Here's the Trivy system namespace. Here's the Trivy operator. I can see if I already have any vulnerability reports. I do. So here are my vulnerability reports, my misconfiguration reports, infrastructure assessment report, and then cluster compliance report. Look at the RBAC reports, RBAC assessment report, and exposed secret report. Okay, these are the different reports that the Trivy operator will create within your cluster as Kubernetes resources, since the Trivy operator is Kubernetes native. And this is ultimately how you install the Trivy operator through Terraform. So let's look at how we can install the Trivy operator through ArgoCD and manage it by ArgoCD to follow GitHub's best practices. So I have here within the same repository a directory called ArgoCD, and that has one resource, the Trivy Operator YAML Manifest. And this is basically a ArgoCD specific custom resource definition. So this is basically provided to ArgoCD running within my Kubernetes cluster, and it's of kind application. It's as part of the ArgoCD API extension for Kubernetes, and we specify here that we want to install the Trivy Operator Helm chart from the repository URL that specifies our Helm chart repository. And then this is the target version that we want to install of the Trivy operator. And here we can again specify the values that we want to change within the Helm chart itself. Now the destination specifies which cluster we want to install this, or like apply this application to, and then ultimately install the resource in. And then the sync policy is describing how ArgoCD is supposed to manage our Helm release, our Helm chart. What do you need to run or like to apply the ArgoCD resource? Well, you need to have kubectl installed, ideally. You need to have access to a Kubernetes cluster, also. And then you need to have ArgoCD installed. So ArgoCD, how do you install it? ArgoCD has an amazing getting started guide that's also linked below in the description. And in this getting started guide, you can see how you can apply the different Kubernetes YAML manifests that run ArgoCD. So you create a namespace for ArgoCD and then you apply those YAML manifests. Now you can also install the ArgoCD CLI, because that will allow you to easily access later on the password that you need to open that localhost, the UI for ArgoCD. So we can go ahead and access the password. So this is our password, and then we can do a port forwarding. So we copy this, then we do port forwarding, and we can copy our password, and we can open up ArgoCD through localhost 8080. The username is admin, and then the password is the password we just copied, and we can sign in. And as you can see, there's no application yet that's managed by ArgoCD. This is all empty, and this is how it's supposed to be, because now we're going to provide the ArgoCD with our application manifest for ArgoCD. So if we look at our Kubernetes cluster right now, K9s, we have within here, we have our ArgoCD namespace. So if we look at namespaces, we have our ArgoCD namespace. Ignore the Trivy system namespace, that's supposed to be deleted, and we can delete it actually for now. So it doesn't exist. So ArgoCD, and within here we have different pods running that all run ArgoCD, everything. We also have a service for ArgoCD that allows us to access the different components. And that's all running through ArgoCD. Now we want to go ahead and we want to apply that resource. And we can just say kubectl apply file and then ArgoCD, basically everything that's within the directory. And I'm here within the Terraform directory, so I'm going to exit that. I'm going to say kubectl apply file ArgoCD, and it's going to install this chart or this YAML manifest. And it specifies it that it's supposed to be installed to the ArgoCD namespace. So if I now open K9S and I go to namespaces, we have here the Trivy system namespace that just got installed 12 seconds ago, as you can see here. And within the Trivy system namespace, we can see that there is a vulnerability scan. That's a job that's happening right now. As Trivy spins up, it spins up different jobs that produce different reports, for example, vulnerability reports and the other reports that I've shown you earlier as we installed the Trivy operator through Terraform. Now that we have installed here, what happens is that, and then if we refresh the UI, we can see here that the Trivy operator is now part of our application, as well as all of the resources here. So as you can see, the Trivy operator also has its own reports. So it has vulnerability reports, it has misconfiguration reports. These are all connected to the Trivy operator pod, because ultimately within the Trivy operator, each report, each scan report is connected to the replica set or deployment that scan belongs to. So if I delete that replica set or deployment, also the scan reports are deleted. Now in this case, you can really nicely visualize it with ArgoCD, how the dependency between the different reports, between the replica set and the different reports. Now, if you would manage other applications through ArgoCD, you would see like also the dependencies between the different resources within the UI as well. Now, if I go ahead and I'm actually going to delete the pod that's running Trivy operator, ArgoCD is responsible to immediately spin it back up again. Now, I could do the same with the deployment. So I'm going to delete the deployment here. And the Trivy operator is then will sync ultimately my cluster or the state of my cluster with what it's supposed to do. So ArgoCD is supposed to make sure that the Trivy operator is always running within my cluster, the deployment as I defined it. Now, if the Trivy operator is getting deleted, if the deployment is getting deleted, then ArgoCD has to spin it back up. And this is ultimately how ArgoCD works. You can check out more videos on ArgoCD on my own YouTube channel if you're curious to learn more on how that works. As always, I really hope this video was useful. It would mean a lot to myself as well as all of the contributors who make Trivy operator and Trivy possible if you could give us a star on GitHub. Also, do subscribe to our YouTube channel and give this video a thumbs up if you enjoyed it to make sure that other people see our content as well. It would mean a lot to myself as well as to the entire Trivy community. Now, I really hope to see you in one of our upcoming videos. Have an amazing day. Bye-bye.